All right. What's up, everyone? Welcome to week 77, Shell Kernel Hacking for Fun. Welcome back. Glad to have you here. All right. Today we're going to be working again on the tool chain. And so last week we ported to Clang. We were using GCC previously, but there's a bunch of reasons why we want to use Clang. And so we got that working last week, but the thing is there's still a bunch of other parts in the tool chain that are not Clang. And so like the linker, assembler, like all that stuff is still the GNU tool chain. And also libgcc, which was kind of this annoying thing last week, is still GNU. So today I want to fix that. I want to move the linker and like assembler and like all these other utilities over to the LLVM options for them, just to avoid too many toolchain dependencies. And so ideally we would only depend on LLVM. And then we're also going to figure out something for libgcc. I'm not totally sure I want to use the Clang, the LLVM version of libgcc, which is libclang-rt, because I don't have an easy way to get a version of that that's compiled for 32-bit x86. So there's another option, which I am super curious to try out, which is this thing called CC runtime, which is from the people that run the OS Dev Codeberg organization. And this is super interesting. I want to see if we can use this to replace libgcc. And the thing about this that's nice, like, so I can include it in my build system. It's just a single.c file, so I can just build it with the rest of my OS. With libclang-rt, I would need to compile that myself, and that, like, I can't just include the source for that easily in my OS's source tree, and so that's a bit more difficult. But this one is designed to be incorporated into an existing OS source tree. So we're gonna check that out. What's up, Suvadeep? Nice to see you, man. Thanks for joining. Hope you're having a good week. Yeah, so I think we're pretty much good to get started here. So that sounds good. Let's just get going. What's up, Buffer? For AA55, nice to see you. Just started learning C. I'm a JavaScript person. Nice. Yeah, I mean, JavaScript is you can do a lot of stuff with JavaScript. I don't know it super well personally, but code for the web, code for the back end, whatever. I want to test out some of my new chatbot commands real quick. I was trying to get this set up over the weekend. I really hope that works. Okay, check it out. So we have a couple commands. Most of the stuff is not new, but the welcome command is new. Yeah, I thought it would be nice to have a little bit of a thing to help new joiners kind of get oriented with what I'm doing, because it can be a little bit opaque if you just drop into a stream and just have no idea what is going on. So I made this little web page on my blog with just a brief recap of like what's going on here. So I have that link there. Hopefully that's helpful for people. And there's some other stuff I want to try out. So there's the top command, and apparently Streamlabs has this function where it like people can get points for like chatting and stuff. So we have a bit of a leaderboard apparently, which is kind of cool. We have top hours. Top hours, apparently it tracks hours or something. And there is what, like the points one. So apparently there's like a points system also. Damn. Okay, so apparently I have 0 points. I guess if you run points, you get to see your own points. So I have 0 points apparently. Okay. Nice. Well, cool that these work. Okay. Suidi, if you want to move away from web dev professionally, so this is a side quest. All right. Nice. Nice. While AI and vibe coding is becoming a thing, I don't like vibe coding as I'm almost 30. Same. So I want to learn low level stuff, how the software interacts with hardware. Yeah. Nice. Yeah, I mean, I'm betting that deep understanding and strong expertise in how things work is not going to go out of style, and so it will continue to be valuable to understand this stuff. I might be wrong. Maybe AI will just be so good that it doesn't matter if humans understand things anymore. But you have more points than me. Dang, how that? Yeah, I deleted, like, I was going through this, like, I get points for chatting in my own chat, which like kind of doesn't make sense, and so I like deleted my points over the weekend. So yeah, very cool. All right, what's up? What's up to the 5-6 people in chat? I guess let's get going. I'll just start getting into the code. So, as usual, what is the state of my working copy? This is not needed. I was just doing, okay, this random C file was from last week when we were just trying to test if the Clang tool chain could support cross compiling, and it does. So I don't need this random file anymore. Yeah, thanks, Buffer. Yeah, I don't know. I think people have different opinions on that, but maybe it's wishful thinking. That's just kind of my take. Oh, okay. It's a bit too soon for a palm tree break, so I will just restart that now. Okay. And I'll just set up with a new workspace for today. It is the 20th. Okay, so what was going on here? Clang. We want to look at the Clang branch. Prevent use of Cindy. What? So what? Here, I low-key tried to use my system LD to compile the kernel. That did not work. I'm gonna delete that hunk. And what was I doing here? What was I doing here? I added a bunch of C++ flags. No default libs. I think I copied these from some OS dev repo or something like that. Wait, what was the history even? Like so we have a couple branches here. The C++ stuff happened on a bit of a separate random branch, and then now for the Clang stuff, I went back to like a regular dev branch with no C++ stuff. So, okay, I think I'm just going, kind of embarrassing. I don't really remember what this, I'm just going to stash this, random CP flags. Most businesses want to see the big picture, so people want to build stuff faster, hence AI is boosting. I mean, yeah. Yeah. I mean, I think AI will affect also this kind of like systems work, and people will be able to do it faster, but yeah. I just think it'll be still valuable to be able to debug things when the AI gets it wrong. Where to learn about these C flags to build? I'm quite confused how a big project in C builds. Yeah, I just like these C flags are very esoteric, and I think I just copied them from like Google or something, like OS Dev wiki pages and looking at other projects. I mean, we can even look back in the streams to see how I found them. I think I just Googled for them actually. Yeah, those random C flags are not like the really most interesting part. They're just sort of esoteric things you need to look up. What's up, Oz? Anything? Yeah, I use GitHub Copilot sometimes. We might use it today a little bit. I do use AI. I try not to have it generate too much code for me, but I do ask it a lot of questions to help just get information faster, just things I would need to Google otherwise. But I try to still write almost all the code myself if I can help it. What's up, Ritesh? All right, so back to work. So I was messing around with like a dumb thing that kind of doesn't matter here. Okay, my normal panes setup seems to have gotten messed up somehow. I will just try to rebuild this quickly. I usually have a lazy git over here. Okay, let's try to build the current. Let's try this clean and build the kernel. Just to make sure we're at a clean building state, and I think we are. And kernel boots. Okay, we're in a good state to get started. So let's take a look at the code. I don't even have my editor open. Okay, here, editor is open. Let me just close everything here. So our goal today, why is this thing still here? I thought, what's going on? I thought I stashed these changes. Okay, whatever. I'm going to get rid of this. I'm going to stage this, and I'm going to stash this random hunk, which I didn't remember about. Stash unstaged changes random flags. Okay, so now we're back here, and the goal is to get rid of this line basically. So here we are calling GCC with a special argument that prints out the path to the libgcc.a file, which comes with GCC, and you need to include that file, that .a file, with the rest of your object files when you link, because the object files have references to functions in libgcc. Let me also, my chat is hidden, 1 second. What's up, Useless? Nice to see you. Asking a dumb question. A kernel is basically a terminal. What's the difference between kernel and a BIOS where are SROMs. Again, I'm dumb, so don't laugh. No, not a dumb question. Like, not a dumb question at all. I mean, kernel and a BIOS where our OS runs. And so, I mean, the current, so maybe just starting link fail. Yeah, so there's this problem where like links cannot be shared. So I think we have to use workarounds like weirdly inserting spaces into the link and stuff. I think it's a YouTube stream thing where it doesn't allow links in stream chats or something. But just real quick, I mean, a kernel is the core of the operating system, and the relationship with the BIOS is that the BIOS is like the really like first code that runs on the computer at all when it starts up. And there's a long journey through the boot process, and the BIOS is the first thing. And then the BIOS generally loads a bootloader from some sort of storage medium. It could be a disk, it could be the network, it could be an SD card, it could be a USB stick. It's like basically anything. It just pulls a bootloader from somewhere, and then the bootloader's job is to find the actual kernel and then load it in there. And so that's just sort of the series of steps there. But the kernel is just the core of the operating system. Yeah, it takes over, I mean, not directly after the BIOS, but after the bootloader, basically. These lines can be a little bit blurry. Like the line between bootloader and kernel is like a little bit of a blurry line, because certain things can happen, and they both run with equivalent privileges. So there's nothing you can do in the bootloader that you cannot do in the kernel. And so you can always do the same things. It's just a matter of kind of like what, from like a design point of view, makes sense to have which component be responsible for. All right, so just to really observe what is going on, I'm just going to click build one time, and then stop. What? Okay, we actually can't see it because it was building. Oh wait, yeah, the libgcc thing happens in the link step, I see, which is maybe a little bit hard to see. Which should be here. Oh, here we go. So here is at least one. This is what it looks like. We have a path to like gcc something libgcc.a, and that needs to get included in some of these command lines. I wish I knew how to search in tmux. I'm just gonna ask super quickly. How to search in tmux pane. Control B then, yeah, okay. Why did that not work? Oh wait, I see, it's just this, libgcc. So we can already see a number of what this thing kind of looks like. So now let's actually like get going. So to replace this, we're going to use this thing called cc runtime, which I have already downloaded into here. And it is just this. What I think I will do is literally just copy this thing into the project. So I'm going to make a directory called third party. And I'm just going to copy misc cc runtime third party. Damn. Useless to use that one too. Nice. Yeah, like really these people that, I mean, Minsky and whoever runs this OS dev thing, like they make some pretty useful utilities for people doing OS development. So this is sort of like the typical kind of janky way you include dependencies in C. You just copy things into your project. And I'm hoping that this is just a bit of a start. It might be a good practice to just include some information about the I don't know, the like commit or something, that this is, just in case I care about that later. So what commit is this? This is DA something something. Okay, so I'm just going to do a commit where I add cc runtime. So that's just a commit. Okay. Okay. Oh yeah, useless has 20 points. Pretty high up there. Much more than my 0 points. Okay. So now we have this, and the idea is, yeah, so this is like a source file that we're going to need to build. And what is also a little bit tricky is that this thing has one dependency, I think. It's not directly stated, but you can see that this thing uses a couple of these C headers, maybe more. I mean, why am I looking at this in the web browser? I have a text editor. Okay, that's cool. Apparently it uses exactly 3 C headers, but I don't, like, my OS setup doesn't really have like good C headers. It never really needed like these official-ish C headers. So in order to get them, we can use another helpful project from this OS dev organization, which is the freestanding C headers. And there's a couple different versions. There's also this 0BSD one, which is super minimal and has basically exactly what I need. At the holy mind base now. Yeah, we're getting there. Absolutely getting there. So I don't know. I'm wondering if it would be nice to have this thing though, which is a more complete set of headers. And I sort of not totally sure if you need to do anything other than just like include. So this is just a larger set of headers, but the key question is, does it have the ones we need? So limits stood bool and stood int. So it does have these. So I am sort of inclined to just go with this. And I think I actually don't have them. So I will just clone this. Mandatory, why not use nix? I actually don't really know what nix is. Oh shit, I made the readme in the wrong directory. Oh shit, there's actually two, fuck. You know what, maybe this readme.md file is going to be, I'm going to rename it to versions.md, and I'm going to call, we're just going to cc runtime. It's going to do, something like this, who cares? All right, so, oops. So I'm just going to amend this into this commit. So now it just has the versions. And now I can go and git clone freestand C headers. And I actually freestand C headers. C headers. Okay. Okay. And I'm just going to delete the Git repo internally. Nix is weird. All right. So now I can make another commit that's just like, dang, this is a long list. Can I go to the top? All right. Add third party. There's got to be some way to scroll through this. This is crazy. Oh, is there? Can I use this scroll bar? Nope. Okay. All right. So we're just gonna say add freestand C headers, I believe, and so. So dash, we're trying to replace libgcc with cc runtime. They include SIMD headers as well for each arch. Yeah, I guess that's the big one, yeah. That's actually very, very useful. Yeah, good to have that. And so these functions are like the internal GCC helper functions for like math stuff. And apparently that's needed. Apparently we need them. So we're just trying to, yeah, get away from GCC if possible. Okay, so now back to the make file. So now I guess I need to figure out how to build these things, and I sort of don't know what I'm doing, but I guess I need to make a touch make frag third party make frag, and here's where I sort of don't know what to do. What goes in these make frag things again? Let's say I wanted to look at what's a simple one? Yeah, so Clang, yes, Clang has a lot of advantages over GCC. I mean, I haven't really needed Clang until very recently, but the super concrete reason was when I was trying to add C++ support. There's certain features that are heavily used in the C code base. It's page dirt. Specifically talking about, it's like this feature supported in C where you can have the globally, like statically declared array, but then you can initialize specific elements of this array, but it all happens at compile time. That's a C feature, and it's not for some reason, that feature does not exist in C++, and GCC does not support it, but Clang actually does support this feature as a language extension. And this feature is used all over the code base, and it's actually kind of useful for just creating these, what are effectively global, like, lookup table kind of things with just constant data. And so that's one reason. In general, Clang just has better, it's a more modern compiler. It has better support for tooling. Yeah. It has built-in cross-compiler support, and so with, oh, it's already time for a 20-second break. Feel free to stand up and stretch for 20 seconds with me. Right, so what was I saying? Clang also has native cross-compiler support, which is kind of useful because to cross-compile with Clang, all you need to do is pass a different -target argument. With GCC, you need to actually have different binaries on your system. So yeah, so there's a lot of advantages of using Clang. So I'm just going to copy in this thing. I sort of don't know. Basically, so now we can make a bunch of rules. And so the freestanding C headers here, ready to be used, and then we have the CC runtime, and so we basically need to make a rule. What is boot objects used? So I don't think that's necessary. I think none of this stuff is necessary. So we want to make a objdr third party. I mean, strictly speaking, this is just for C runtime, but for the moment, yeah, I'm just going to copy path, copy relative path. And this becomes an ampersand. So we're just making a build rule that's going to tell the build system how to convert the C file into a compiled file, and there's like this random cruft from the makefile build system. And then here's where we call the compiler. And we want to compile this basically just like any other kernel source file. And so it's correct to use current C flags and stuff like this. We don't need the OS. That's like a particularly weird thing that the boot code needs to make it as small as possible. So the normal command line looks more like this. So, and we have one extra thing we need to do. But with this build rule, I can already just try to build this thing, and I think it's going to fail. Because I haven't yet set it up to find its includes yet. So if I just clean and I try to make objdr third party cc runtime.o, this is going to trigger this build rule. except I sort of am doing it wrong, because technically I could use a CC runtime thing here too. If I want this to really replicate like the build folder directory structure to really replicate the source one, I would probably do CC runtime here too, but that's, I think, to do could, I don't know, I'm not even going to mention that. So I think we can just try this out, and I think it's going to fail, just like I expected, because it can't find the limits.h. So we need to allow it to find that. And I'm just thinking about the best way to do that, because we need to use the -I flag to GCC. And obviously I could just hard code a path. Yeah, I think I'll just do this. So free stand C headers I686 for some reason is going to be, and I guess it's like, are we using paths from the root of the project? I guess so. Okay, so here's the -I thing, and now when we pass this to the compiler, it's going to know to look into this folder to find any included headers. So if I do that one more time, it still didn't work. What happened there? So we can see the -I thing. Just to really oh, it's include. Okay, that's why. Include. Okay, one more time. One more time. What? Okay, this is unexpected. So this is a problem in studint_h itself. Whoa, studint.h. For some reason, it is trying to do this. It's looking for my system's studint.h for some reason. If studc hosted how did this get set? It seems like we're kind of falling into this thing. This is a little bit more difficult than I expected. If this symbol is defined, then we hit this otherwise we want it, but this is what we want to use. So the question is, why is, like, what is going on with this thing? And is it a CC runtime thing? Holy crap. F freestanding. If not, so I think we need to pass the freestanding flag. Apparently this corresponds to freestanding. If it's not hosted, do this. If it... So just a quick thing we can try is passing a freestanding, which actually I think we haven't really been using so far. Yeah, let's try that one more time. Okay, so now with the freestanding flag, that works. Check it out. Very interesting. So today I learned that this is like so obscure. Freestanding sets stood c hosted and GCC headers check if we're in freestanding. If we're in freestanding mode and only use the internal student.h if we are in freestanding mode. So we must define f freestanding, which makes sense. For some reason, we just didn't really need that so far. Okay, so that's a bit of a step forward, though. So we got the CC runtime to compile. So now time to figure out actually where this freestanding flag should go, because presumably the other currency flags. Presumably other things could use it too. So we just have our normal C flags, or sort of like our global set of C flags. Yeah, I mean, I don't know I actually don't really know what freestanding does, to be honest, like, because there's all these other flags that we pass too. There's like no stood inc, right? For some reason we're passing no stood includes there, and that's what's preventing us that's what's preventing the compiler from looking in system include directories. And yeah, and then you get, probably libc too. So but yeah, there's like no stood inc, there's no stood lib, and I think no stood lib might be the one that actually prevents libc. Let's just ask, what do these do? F freestanding, no stood inc, no stood lib. Disables assumptions about standard library and startup, blah blah blah. No stood inc, don't look in standard system library directories for headers. No stood lib, don't. So I think to be technically accurate, no stood lib is the thing that prevents linking against libc and crt0. But they're like, it's very confusing because they're all like kind of related in different ways. So we're passing nosted lib apparently also. I think I might just add yeah, I might just add this here. Freestanding third party make frag. So I'm going to remove it from this header file. And let's just see if the kernel builds. I mean, there's no reason why it wouldn't. Basically, we haven't done that much. We haven't changed. I mean, that was really the only thing that would possibly affect the kernel build is like passing this flag here, but that doesn't seem to have any effect on the normal kernel build. And now we don't need to have this over here. And now we're actually super close to being able to replace libgcc because we have it built. So what I will do is just demonstrate the breakage that occurs if we just don't have a libgcc at all, and we'll just see the build fail in the link step right here. So it's trying to, in this case, it's trying to link one of the user programs that just happens to be first in the build for some reason, but it cannot link against this function. So now this would be pretty cool if it works. What we can do is objdr third party cc runtime.o, which I'm pretty sure that exists, except it does not make there. Okay, interesting. Oh, okay, so we need to add a dependency. This might be a little bit annoying. But anyway, like, the rule does run and we end up with ccruntime.o right here, which is, like, we can pass that instead of libgcc.a. We just need to make sure, we just need to figure out a way to make sure this builds before all of the things that need it. And the way you do that with make is you express dependencies. And maybe this will not be that hard. We can look at all the places that use gcclib, which I hope was not too many. And for example, the kernel. So what's kind of interesting here is this rule uses gcclib, but it doesn't depend on it. And so I actually wonder if, I think this will work. We just need to make sure to depend on gcclib also. And we just need to do that anywhere it's used. Why does this not have syntax highlighting and this does? File type, file syntax. All right, what's the language mode? Make file. Okay. Yes, the variable is called gcclib for the moment. Yes, it contains a path to the cc runtime thing. But it's a good point. I'll probably rename this gcclib variable when I'm done at the end. But for the moment, just to make this as easy as possible to get working, I'm just going to keep it named gcclib right now. And just add it in They're not so many places that it's actually used. So apparently it's just used 1, 2, 3, 4, 5 times. So now let's try it. I think this is going to work, but let's see. So I'm gonna clean the build and make. And oh, what? Holy shit. That's hilarious. We somehow this thing got like included way too many times. Okay. What's up, Psyophantasia? How strict are you about warnings? I see you got wall and wearer. Oh, 20-second break. Be right back. Yeah. Yeah, Psyophantasia, I'm trying to be pretty strict. I would like to be pretty strict about warnings. And yeah, W pedantic, true. I think I should use that. Yeah. I don't know why I wasn't even using it. Pedantic? Yeah, and I think there's just no reason. Thanks for the suggestion. Yeah. Yeah, appreciate that, Dash. Thank you very much. Yeah, just how I go about problem solving and just getting stuff done. So, what happened here? Okay, first of all, what the this is it. Oh wow. We're getting all sorts of warnings. Yeah, all right, maybe this is going to be a little bit harder than I thought. What is going on here? In function, blah, blah, blah. Multiple definite dwarf error. Holy shit. So what is going on? Okay, I don't really get the problem, but my suspicion is that CC runtime... Okay, no, CC runtime O is occurring twice here. Why is that? What? It's not when it's building CC runtime, it's when it's linking the kernel. And it's because I'm including the object file twice, I think, for some reason. Let's go back to the net make frag. Oh. Man, entry.o. Oh shit. That's why. If we include, okay, it's because of this. Okay, it's because of sorry, get my chat popping up back again. Okay, it's because of this thing in the makefile. This thing, these two characters, basically inject everything in the dependency list into the command line, which is actually very useful, so you don't need to repeat yourself. So actually, I can delete these lines for anywhere it's needed. That's cool. Okay, I think this is the last one. So now we are just, well, as long as all of these things actually use. Okay, wait a second. I'm going a bit too fast. I think we actually do need it here still, because this rule does not use that $ less than thing. This rule uses it. This rule uses it. This. Okay, no, this rule did not use it, but maybe it could. I mean, it's because it sort of seems like we. Actually, I'm kind of confused. No, it's actually this. It's this thing. Wait. I think. What is what does do in makefile? The name of the current target, so that's not it. Okay, whatever. I think the main problem was just this thing, I think. So actually, is it being used over here? Actually, no, it doesn't seem like it is. I think I still need it. So it's like just in that one weird place in the network code. Let's try that one more time. Okay, wait. What did I do? I messed something up. Pardon me, frag. What happened? Why? What? All right. Is it the freestanding? No. Undefined reference to main, to you main? No way. What's going on here? We're linking test output. Test output, blah, blah, blah. Somehow test output dot C is missing from the list. Did I break that? Did I do something stupid to break that? I wonder if somehow it sort of seems like because I put this thing first, that is weirdly broken. I don't totally get it, but I'm just gonna try it. So if it's kind of stupid if I just put it at the end. We're just missing, like, we're missing test output.o in this command line. Did we even build test output.o? No. And is that because I broke something here? I didn't touch this part. Oh, wait, what? No, I'm confused. Make clean. Let's just watch this. It's trying to link test output, but it never built it. Also, I'm like pretty concerned about all these warnings. That's like kind of scary. Okay. What to do? I feel like I want to look for errors. Is the word error up here anywhere here? Did something fail to do something? No. It takes about 20 seconds, I would say. Maybe less. No, I think less. More like 10 maybe. Does this take? I'm assuming you mean the whole project. So what? Why is it linking? Wait, and also it literally compiled it right here. Obj net test output, and this string obj net test output.o needs to be somewhere here, and it isn't here, and it's not totally clear what I did to break this other than just include this weird GCC thing at the end. What if I just comment out my change? Does it fix it? Possibly. So we're still relying on it, even though it's not an explicit dependency, which kind of sucks, but let's just try it again. lifetime honor tradition of fucking with make files. Yeah. Not my absolute favorite thing in the world to do, but I do have to admit it is like kind of fun in a weird way. Okay, so I think this hunk is a red herring. The only possible option is the F freestanding, but that also doesn't make sense because this thing is a user program and we don't pass kernel C flags to it, but just to be ultra safe. But if I get rid of that, then I need to add it back. This is annoying. Okay, if I get rid of this, I need to go need to go here and add it back. I'm just trying to really narrow it down. That is so jarring to watch. What? But the build worked before, right? At this point, I sort of want to just drop or like stash all. Oh wait, no, I know. No. Okay, I was looking in the user, but we're actually looking in like this is like a net program, so I was looking in the wrong place. Oh, I think I know the problem actually. I think, what does this thing do? I think this thing takes the leftmost dependency or something weird like this. What about? Yes, it like weirdly takes just the thing on the left. So, okay, so never mind. I'm being a bit foolish about that. Net make frag. So this thing needs to come, did I do that right? No, shit, I did not do that right. DA lam 0 P and I need to do the same thing. Show P. Okay. Wait, actually, so I think I need to put this back now. Because I misunderstood what that arrow thing meant. It's not the whole list, it's just the leftmost thing. Okay, I think hopefully this should work now. That is so jarring. Okay. So we fixed that error, but now we have another problem where this thing is not getting... And I think that's because it's like this thing, GCC, for some reason this thing just never even... What are we linking? We're linking the kernel? What the... different scheduler other than round robin? To be honest, no. I'm like really not. Well, okay, maybe. Scheduler is not really an area of interest for me. So I don't, yeah, I think other things I would want to do first. So this is interesting. We're linking the kernel. We include the cc runtime .o. And we are still getting the same build error as if we did not include the CC runtime. So that begs the question: what is in CC runtime? It's like it seems like it doesn't actually have the thing we needed. Okay. And CC runtime.o. Let's check this out. Holy shit. Readelf gives a bunch. Unrecognized form. So u mod di, right? U mod di3. I feel like it looks like it's there. Right? udiv u mod di3 u div di3 oh what? Okay, this is confusing yet again. I am confused because this file is getting passed to the linker. Time.o. Damn, what do I do? Okay, time for a break. Be right back. This is so mysterious. Maybe it's time to ask the AI. Here's what I'm gonna do. Maybe, I don't know, maybe I'll just try GPT. Here's my linker error. Here's my readelf output for cc runtime.o. Can you? I don't understand. I feel like the symbol should be there to be linked against, right? Oh, fuck. It's right. That's true. Wow, that is subtle. And so, okay, the problem is that this dash B binary thing. So, okay, what? So we have this thing because we actually include a bunch of, like, before we had a file system, the way we included user programs to run was by like baking them into the kernel binary, which you can bake arbitrary data into like binaries with the dash B binary thing, But the way this thing works is that everything after -b binary is considered a binary file, and it's not considered for linking. And so we just need to include it before -b binary. That is interesting. Okay. There we go. And it built. We have 10 million warning lines. But it built successfully, and even better yet, let's see if it runs. And bam, it runs. Check that out. That's sick. Nice. That was a little bit harder than expected, but a bunch of the problems were just self-inflicted by me. So that's very cool. I have all these new lines. So now I'll just clean this up, get rid of the new line, get rid of the new line. And yeah, so make frag. We actually want this one. Okay, that. And now I need to go and revert this change. Can get rid of this. But wait a sec, I can do this step by step. So first off, I actually don't need to stage all this right now. First, I just want to make a commit where I can build the CC runtime. And to do that, I just need this hunk and this hunk. I don't need this one yet. And so our commit looks like this. Yeah, well, so I'll just commit it. I mean, so yeah, so we have our actual build, and then we have the minimum update to the make file to add the freestanding thing and include the make file. What's the commit message here? And build CC. Add CC runtime to build system. This is lazy Git, the best Git client ever, sort of. Some people I know say that is. I still bounce back to fork quite a bit, but it is super awesome. You can do things so fast in lazy Git. Except for when you need to scroll through this window if you have like a billion files that you added. That there's probably some way I don't know to get around that. And my user, this is frustrating. Why is there a space there? Okay. And all right, so now back to over here. So now we need to figure out, let's see, lib, what to do with this thing. So we can delete all of this. Or disable runtime library for kernel. What does that mean? Okay. I guess we just like hard code this path. Not the loveliest thing, but I don't. I mean, what's the? So this thing is not actually used anywhere in this file. I sort of wonder if I could actually move that to this file just to keep it a little bit closer to where it's actually used. Can I make file? Okay. I really do not know the makefile rules around global variable scoping and stuff, so I don't know if this thing can be used by the other make frags, but let's just test it and see. Seems like it's working. Seems like it works. Okay, that's cool. I like that. So I will just stage all of this. So I'm going to commit build everything using CC runtime. Right, so that's the commit. We just what? Actually, okay. Here's where LazyGit is awesome. I'm just gonna so I made a mistake in that commit. I didn't mean to have this comment in there, so I'm just going to delete it right now. And then I can just super quickly amend it instantly, like into this commit. And so now I've fixed my commit and amended it. So, yeah. Yo, digitalized, what is up, man? Oh. How are you doing? We just made some progress, and got rid of libgcc. No longer using libgcc, we're using cc runtime instead, which is, I don't know. I think it's just libgcc, but like stripped out. And I think it's literally libgcc. Oh, no, it's LLVM's compiler RT, but it's just stripped out. Yep. So the only last thing to do here is rename this to what would be a good name? CC runtime lib? It's the compiler runtime library. Dig that. Dang, how do I just accept? I don't do this enough. Replace. That should have been a totally benign change, so that should totally work. So now we just, fuck, what? How did this not get included in my big ass find and replace? Okay. Ugh, okay. There we go. So now we just have a nice clean commit where we just rename, oh shit. We just rename gcc lib to cc runtime lib. Okay. So that's baller. Took a bit longer than I thought it would take, but now, so basically here's the roadmap that we're kind of trying to progress through. On the left was where we started with this GCC and GNU only in our tool chain, and we are trying to get all the way over here to a Clang LLVM toolchain only. And we've been making baby steps along the way. The first step last week was switching the compiler over to Clang only. Next up are these other 2 steps, which we have now officially done this one. Where is the pen tool? All right. We've officially used CC runtime. Right. And so now we're basically almost there. And the only thing, I mean, these are basically the last option. The only thing we need to do now is replace all the rest of the items in the tool chain with the LLVM versions and stop using the GNU tool chain. Yo, what's up, Marcus? What's up, IDK, bro? What's this tracking? Check out this link. I don't really know what your question means, but if you're curious what like I'm doing, I have like a little blog post to help people catch up. Oh, what's this? Oh, the Miro? Yeah, this is just like my my enormous project board for all the work I ever did on this OS streaming project. Yep. Bruh. Yeah. All right. Yes. So LLVM, yes. Absolutely. LLVM does ship with their own building utils, and all we need to do is use them. And I'm hoping that should be pretty easy. So check it out. This is the part of the code that's relevant. Here's the part of the code where we... Actually, wait a sec. We don't even need this GCC thing anymore, right? Oh, what the hell? NCC. This is hard-coded to use GCC. That sort of sucks. Who's using NCC? Dang. Alright, that's not good. I need to make this... What's CC version? I need to make this say clang or something. I don't even know what the CC version thing is. So this kind of slipped by me. This was like just a weird hard-coded use of GCC to build, it's like this tool that runs as part of the build process to build the file system image. I'm hoping it should be this simple. Let's just, can I only remove, like what's in the file system dir? Files. Okay, so if I just blow away the file system thing and then rebuild, it won't need to rebuild the entire kernel, hopefully, but it'll just rebuild the necessary portions, and we should hopefully see that it's using Clang here, and that it just worked. So that's good to just fix up. I'm just going to actually amend. I'm going to drop this, and I'm going to amend this into my original commit. Use Clang instead of GCC. I'm just going to, so for anyone watching that is wondering why I use LazyGit, here is a great example. I have a change I made, but that change actually should have been in this commit earlier in the history. And I can amend this with a single command, which is the capital A command, directly back into that commit without like manually rebasing or anything. Because usually the -- amend flag on git commit or whatever only works like one commit back, but with LazyGit you can go arbitrarily far back in the history. And so I just amended my commit that ported to use clang. So, yep. All right, let me check in on the chat. Yeah, okay, so IDK bro, I used to work with Ubuntu. What's your day job now? I mean, I never worked like for Ubuntu, but I work in the music technology industry. I work on music production software these days. Yeah. Useless got a VFS. Is about to start with a VFS. Got processor working. Sick. Right on. Read blog posts. Found a memory corruption bug in LLVM. Not quite. I found one in LLDB. Just to self-promote myself. Where did I talk about that? I talk about that on my about page, I guess. Yeah, this is one of my most prized possessions, a memory corruption bug in LLDB that I found and patched and stuff. Yeah. What's up, John? Nice to see you, man. Also, what's up, Miho? I hope I'm pronouncing your name right. Nice to see you again. Yes, we were having like a lot of success with using Clang. It's very close to being an LLVM only toolchain at this point. Using Clang as the compiler, and now we're not using libgcc anymore. We are using this CC runtime thing, which is sort of like an extracted version of LLVM's compiler runtime library, but extracted to be usable and embeddable into other projects. So now we're using that, and that leaves basically one thing, which is, okay, actually no, so we don't even need, I mean, there's like all these, all this GCC stuff. We don't need this GCC variable though, actually. That can go, right? That's not needed for the build. So actually that would be another candidate to amend somewhere. Let's go with unstage changes. So where do we amend this to? Probably here. Here's where we actually use the GCC thing, so we can amend this here. GCC gets removed, this thing gets removed, and then this is added here. All right, so now what do we need to do? So now I was sort of testing this earlier, but now the idea is to use the LLVM toolchain that I have installed via Homebrew. Where was I testing this at? Was it in this thing? Anyway, so I mean, it would actually be even cooler if I could use the, all right, 20-second break, be right back. Okay, so technically, something is a little bit weird right now with the setup because I'm using the clang that like comes with Xcode or something like that, and weirdly that actually does support 32-bit x86 for some reason. I forget if I actually tested. Did I? I mean, I think. Okay, this terminal history very much makes it seem like I was testing this. What did I do? I was running clang. Okay. Oh yeah. Right. So okay. So the LLVM toolchain with Clang does support 32-bit x86. So probably it actually would be good to use that. So one like tiny baby step that I will just do is just try that right now. So instead of using just normal Clang, we'll use my homebrew Clang because that's probably a bit of a better practice. And that seems to be working. Okay. Cool. I'm just gonna go ahead and also amend this. Into here. Actually, now that I probably want to just do. Doesn't really matter, but yeah, that problem, Miho, with the ARMv4, that I don't really get that. That was just because I didn't add the -c. Well, I forgot to add -c when I was doing these tests, and so it was actually trying to link the object file. Yeah, I don't know. What's up, Anand? Project is compatible with all kind of kernel versions. This is a custom kernel, and so it's just what it is. It is. But I guess if you're asking if it can run binaries for other operating systems, like no, very much no. It does not. It does not export like a Linux ABI or something in any way at all. Yeah. Okay. So this is like their just to really make sure, because I'm paranoid. Oh, did that actually break? Wow. So it actually seems like that like broke something. What? This was supposed to be the least controversial thing ever. Just like instead of using Clang, use like this other Clang. Wait, what? Yeah, so that worked. Yeah. Quick pause. For the people that have showed up a bit more recently in the chat, I want to point out that there's a bunch of new chat commands that I added over the weekend, including this awesome chat command called top, which is like some kind of leaderboard or something like this. And so I just want to make sure you all know that you are getting points for being in the chat, in case you were not aware of this. Because I know about a bunch of you, like Digitalize, Michael, like y'all are coming a lot, and so I want to make sure you just, John, you know that you're getting points in case you care about that. All right. So this is interesting. I am a little bit surprised that I cannot just replace this. But maybe it kind of makes sense. Maybe it kind of makes sense. Technically, it sort of actually does make more sense to just use the word clang here. The goal is to actually use the system host compiler here, and that, like, this thing is not the system host compiler. This is our cross compiler, just for this project, and so it sort of makes sense to do things differently here, actually. So I'm just not going to worry about that too much more. I'll just go ahead and amend this back into use clang instead of GCC. Shit, what's the conflict? All right. Conflict is that at this point in the history, this GCC line still needs to be there. So I'm just going to add this back. Shit. Damn. What the fuck just happened? Wait. Okay. Somehow I completely messed that up. Let me abort that. Shit. What happened? Oh, this fix up? Right, let me just try that one more time. Okay, maybe this is more trouble than it's worth. Okay, so now the GCC line goes away. Please, okay. Hopefully I did not mess anything up in that thing I just did, but looks like we're good. Now we are finally in a position to be able to attempt prefix. Something like this. Right, so now we have that, but now, I don't know. Well, let's just take a quick look actually at, like, what is in here? This is my homebrew LLVM place, and we get a bunch of stuff. We get a clang. We get an LLVM-AS. Obj copy, obj dump. Do we get an NM? nm ld lvm. All right. Is it called LLD though? LLC? Wait, what? There's no... Is LLD... Like, what? Okay, so... I don't have a linker. LLD is a separate package. Ah, interesting. Okay. Let's grab it. Install LLD. Okay. So thank you. AR and AS though, those are there, right? AR, AS, okay. Tremendous scam that broke my... Yeah, huge scam for sure. Custom Android build a few years ago brings me back. Fun times, yeah. All right, so I think... All right, so what's the deal with LLD then? D? Okay, we got an LLD. So fix so obviously hard coding these paths to like on my computer into the build system is a poor practice, but that's how we're rolling for now. So just as a test, what if I just tried to replace AS, except it needs to be all right, so these are bin. I guess I need to do this. What happens if I just replace the assembler? Like, does that work? That seems to have worked. Okay, nice. So maybe I can be a little bit more aggressive. Let's try that one more time. Shit. Oh wait, now I need all of these things. Dang. No. So did that not work or something? User hello, damn. Something is going on. No such file or directory. Okay. Weird. So this error is happening. Maybe I will rewind slightly, like what about if I replace it with this normal obj copy? What happens? Okay, that's where. Okay, so for some reason, LLVM obj copy breaks things. That's weird. Okay, but for the rest of these, seems to work. And then I guess LLD is going to be the other question mark. Is that how you do it? It's just LLD. Okay. All right, let's try it. LLD is a generic driver. I guess I use LLD.LLD then. Can I? Oh. What? Oh, fuck. What? Output file 2. What? LLD is the linker. LLDB is the debugger. Ouch. What? Truly, I don't really know what to make of this. Output file too large. Any idea about this one? This is a known issue. With a whoa. Oh, back to GNU LD. Wait, okay. This is weird. So, linker. Try using gold. Oh man. Is gold an LLVM project? Actually, what? Yeah, gold linker. Oh, it's a GNU gold linker is deprecated and will be gone for good. Ouch. Okay. So what are we doing? We're linking a debug version of a user space binary. Yeah, F's in the chat for gold linker. Ouch. User make frag. What do we do here? So apparently when we have these user programs, we build two, no. This is actually kind of confusing. I only see the part where it links the debug version. But where does it build the actual version? User apps. We depend on the... Oh no, so here, it looks like here is where the user apps get built, actually. So like, for some reason, they're built in the file system. Like build file. Okay. So the issue is related to debug info, it seems. I'm just going to, here's my user.ld. Debug sections not being explicitly discarded in the linker script. All right, let's give it a try. I don't know why I'm not using Copilot. All right, so not super sure what that does. I'm just gonna break it just to make sure it. Type mismatch, what? If I have a syntax error, does it complain? Okay, yes it does. So it really is using this file, and it still has the problem. Okay, maybe I will switch to Copilot and see what it has to say about this. Have this linker error with LD. Oh, what? What? Alright, I'm just gonna kill the palm tree because we're getting close to the end of time. What? It's saying delete? There's no way that's right. All right. that's kind of nuts, but not really that important because I don't even use these debug things anyway. So it's not really worth like even doing any of this really. I'm fine with dropping that if it lets us. Ooh. Move. But wait a sec. Am I? No rule to make. Okay, so wait. So we do need this rule book. This is like very, very confusing. Oh wait. Wait. What's up with the this is. It seems like this is the rule that produces. The actual binary in the end. But it really seems like it's producing this .debug thing. And it also really seems like this is this is like very whack. Okay, this is the file system, but weirdly the file system depends on the file system O files, and then it like wait a sec. Okay, wait a second. Fast. Okay, I misunderstood. This is just building this program that it's building the file system server, which runs in user space in the OS. So this is not at all related to these things. Who's we're just depending on the user apps here. Okay, maybe it builds this debug binary, but then it obj copies and removes a bunch of stuff and then produces the final one. I see. Okay. I'm going to just actually Google this. Man, okay. T-text 0. Some crazy LLD. This is a common pitfall. People think that text is the first section of the traditional concept. You need what? To use image base. Okay, this is not at all related. Oh, okay. This is like gnarly. Yeah, I've heard of mold. I've heard it's pretty good. I think I'd like to avoid adding like too many dependencies. The linker in the macOS SDK is almost certainly not going to work here because it's meant for linking Mac like programs, and we're trying to link a 32-bit x86 like non-Mac kernel. Yeah. So okay, I don't know. It has gotta be, it's something with the debug, and ULD flags. Who is T user LD? Okay. Okay, LD flags. M. I mean, I think the problem, or at least one way we could consider getting around this, perhaps, is to not pass -G. Like, for some reason we pass it twice even. That's like weird. But if I sort of don't expect this to do anything. Let me actually rebuild from scratch. If I totally remove -G, wait, yeah, why did this not get found? So if I just totally remove this, just curious what that looks like. Very odd. But wait, no, yeah, this is the user program. So it is using C flags, but then it's using user C flags. So I don't see any -Gs in there, so what does this command line actually look like? Hello? No standard lib, blah, blah. I don't know. Yeah, that is a... It sort of seemed like ChatGPT had an idea about this. It says replace this thing with the other thing. And that's... I think Copilot generated a scenic lists. So that's what I did. And it still doesn't work. So maybe I'll just say that it still doesn't work. I guess I'm not really even sure what sections and what binary it's even talking about. There's only a couple binaries. Did I give it? Maybe I'll try a different Copilot model. Like, I don't know what happened with this one, but it really sucked. Maybe I'll go in agent mode. Okay, and I will copy and paste it here. Here's my linker error. It seems this is a known problem with LDP. Check online and confirm that. Any idea how to fix this? And what context should I give it? I'll give it the user.ld, add file to chat. I'll just give the whole code base also, maybe. Mac, like, So we are passing elf i386, so that should communicate to LD that we're not targeting Mac. Continue. Continue. Oh shit, why is it still using Sonnet 4? I sort of wanted to use GPT. All right, if it can't find it quickly, I think we'll need to wrap up and leave this for next time. Integer overflow in LLD. So all that, like, actually, yeah, this stab stuff is super sus. I should just get rid of all of this, I think. Let me just try that. Oh shit, now it's really, wait, stop. Don't switch back. Okay, undo. All right, I think we'll just, yeah, actually the stab stuff has been super problematic in the past. And it's possible that it is just causing all sorts of problems. Oh man, that did it. And check it out. I think that also made all those warnings disappear too. Look at how clean that compile is. None of these crazy jarring hex 22 warnings. That is so nice. Wow, just in the nick of time. All right, so so the kernel doesn't boot anymore, but Jesus. But I think that is perhaps due to the messing around with all these -G changes. So I'm just going to revert things into their original state. I'm going to keep the -G basically everywhere. And this was our original hunk that we were working with. I will stage the stuff that we know is pretty stable. and then just leave these two things. All right, let's like run that one more time. Damn. No way, is it? Did this? Okay, I'm going to save this somewhere. But wait a sec. Okay, I don't know. User space is... No, the kernel... Oh, the kernel crashed trying to access hex 8000, which is a user space address. And I don't know why. And that is very mysterious because it seems like this linker thing was related. So let me just, I'm just going to delete, or rather I will, all right, I will just stage that user LD thing, user LD fix. So now we're back in this state where we have this like original user LD, which doesn't compile. Also, what's up, Mark Demivods? Yes, I've been streaming for 77 weeks. This is my 77th week. This thing doesn't compile. But what if I just delete these three things? But then would I leave this the same? Does anything change about that? It should compile now, maybe. But does this affect runtime? Yes, it crashes. Oh, okay. Ouch. That's what I can say, ouch. Okay, so clearly what? So that is problematic. If we go back to GCC, it should build and run fine. Or not. Or actually, wait, what? So is it not a problem with LD? Oh. Nice. Thanks for the hex dump recommendation, Dash. Thanks. All right, y'all, I'm like a little bit cooked right now, so I'm just going to wrap up some notes on this. But But I want it. That's actually very odd. This is not really a great state to be leaving off with it. The kernel no longer boots. When did that happen? And is it possibly related to these other things? So maybe let's really run it back. Prefix. Like, or rather, maybe I'll just make a new copy. So maybe we'll have some LLVM versions. Let's just, yeah, I just want to get this back. Yep. Okay, so we're using Clang, but everything else, GNU. This was the last working state. And we're getting all these warnings, but it builds, and the kernel does not work. Okay, good to know. How did I? So apparently I have not been running the kernel. I broke it. Like the kernel. No way. What even happened? So, right. Was it CC runtime? Was that the point at which it stopped working? Okay, I guess I will just do I'm just going to do a sloppy commit. So what did this do? This is like a commit that it doesn't really do very much, right? This is just using the plain Clang state, and we have a candidate version just right there below, but whip ready to use tool chain, but don't yet. Okay, but okay. Let's just wrap up by figuring out what went wrong where. I mean, so add CC runtime to build system, right? This should completely, absolutely work. That should be our known good state. Yes, so we're good. So we have our known good state, right? Build everything using CC runtime. That's really the only commit that could have broken things, and that's my guess. I'm going to predict that using CC runtime broke the kernel. Yep, check it out. Whew. All right, so that is fascinating, and will yield a hopefully interesting and not too painful debugging experience when we look into it next week. Man, what is going on there? What is going on there? We will see. Otherwise, we are in a pretty good state to do LLVM toolchain stuff. I'll also just, I mean, this stuff is gnarly. I'm just going to delete it right now because it's clear that that was not the cause of the runtime kernel bug. So fix toolchain warnings and LLD issue. All right. Whew. All right, that's gonna be it for today, everyone. Thank you very much for joining. I'll, as usual, just gonna post my link to the Discord. Oh man, I missed some Twitch chats again. I suck at that. All right. Yep. Yeah, man, I missed a bunch of people in the Twitch chat. That's a bummer. I was too focused. Yeah, some people were asking about, yeah, average Debian enjoyer asks about what's the makefrag file. Lazy git. Yeah, all right. Thank you for watching. Feel free to subscribe to my channel if you like what I'm doing. Be here every week, and feel free to join the Discord if you want to chat some more about stuff. And then next week we will hopefully fix that crash that CC runtime caused and fully port to the LLVM toolchain, and then become completely Clang and LLVM based. All right. Well, wishing you a great week. Have a great week, and I will see you next one. Peace.